I hope you guys are happy. Here we go. So what you're looking at is what function is that? Sine or cosine? That's sine. Yay, we all took pre-cal. That's good. What you got to know right now about sine, I guess the steepest slopes, the steepest tangent slopes happen at points of inflection for both cosine and sine. So where are my points of inflection? All right here where those blue dots are at. And that slope is either positive one or negative one. Cool or not cool? And then where do I have slopes of zero? Well, wherever you have a max or a min, you have tangent slopes of zero. See, I have a tangent slope right there. See, does that make sense? So here's what I'm going to do. I'm going to plot it. If you have colored pencils, I'm going to plot my derivative points in blue. The same x value, but I'm going to plot what the derivative is. So I see at negative 3 pi, I see that my slope is a negative 1. So I'm going to go to negative 1, my tangent slope. I'm going to put a point. Let me erase these points here because we need them. Are we okay with that? Remember, I'm just plotting y primes, the slopes, the value of the slope of my tangent slopes. I see that at this value, in between 2 pi and in between negative 2 pi and 3 pi, I have a slope of 0. So bam, slope of 0. Tangent slope of 0 on the curve sine x. Are we okay so far? I see that at negative 2 pi, I have a slope of 1, positive 1. So I go to positive 1 and I put a point. In between negative pi and negative 2 pi, I have a slope of 0. So slope of 0. At pi, the sine curve has a slope of negative 1. So slope of negative 1. What's up, Kyle? Huh? We're good? Okay. Am I just what? Well, that's going to be, you're already ahead of me. You're looking at what's happening. Not yet. Don't tell me that yet. Between 0 and negative pi, so at negative pi over 2, I have a slope of 0. Boom. At 0, the sine curve has a tangent slope of 1. At pi over 2, it looks like the sine curve has a slope of 0 because I have a horizontal tangent there. Do you guys see what's happening? Yes. At pi, negative 1. At 3 pi over 2 there. 2 pi, 1. And bam. What we just did, plotting tangent slopes, plotting the values of tangent slopes. No, go ahead.
What is it called whenever it's like that's the transition?
Well, what we just did, it's not the translation. What we did is we graphed the derivatives of sine x. You know what I mean? So check it out. These are all my derivatives at specific points, the values of the derivatives. So if I were to go ahead and plot those points, wherever you have a max, do upside down bowl. Wherever you have a min, do like a bowl or whatever you want to call this. I guess you could call it. And then make it aim towards the points of inflection and then connect them. Make it aim towards the point. Try to make it have a point of inflection at the axis. And what you just graphed is your derivative curve of sine x. What does that function look like? Yeah, that's cosine x. So we can make the following statement. The derivative of sine x is equal to
Cosine x.
There it is. Isn't that cool? Before, by the way, you've done a formal definition of what this derivative is. We've done it with notes 5 when they told you. Remember they told you this: f of x plus h minus f of x all over h limit as h approaches 0. And you have to do it for sine x or cosine x in one of those notes or quizzes. So you've done this this definition formally, but there it is. The derivative of sine x is cosine x. Take a guess. What do you think the derivative of cosine x is? Negative sine. Negative sine.
Why is it negative?
If you were to do the same thing, you would see sine x, but negative sine x instead of sine x. If we were to do this, if you want me to, we can do it. Find the derivative of cosine, we'll get a negative sine x.
I was just wondering because why is derivative of sine x not negative cosine x?
Oh, you just saw right here. Because when I found my tangent slopes and I plotted all those values and I connected them, it looks like cosine x. But if I were to do the same thing with cosine x and I were to plot the values of the derivative, you'll get a function that looks like negative sine x. Are we okay, guys? Anything crazy? Okay. Let me know if you want to see this proof, and we can do it. We've done it many times. Should we continue? Should we move on?
Yeah.
All right. So here, simply put, and look, we give you the formal, the way it looks in the textbook. I don't like that. Well, sometimes they put parentheses, sometimes they don't, but that's fine. That ddx means derivative. What's up, Kyle?
Sir, can you do that, the derivative of cosine x equals negative sine x?
Yeah, we're just going to need the space here. Yeah, we can do it. Not a big deal. Here we go. So if I want to know, you want to do it formally, right? All right, so here we go. F prime of x equals limit as h approaches 0 of f of x plus h minus f of x all over h. But you don't want me to do sine x. You want me to do cosine x, right? Okay, so semicolon, if f of x is cosine x, then comma, f of x plus h is cosine x plus h. We still okay? All right. I'm going to put the property that we need. Where do I put it? I'll put it right here. We need this property. Cosine A plus B is cosine A cosine B minus sine A sine B. Yeah, we've done this. We've done this many times in pre-cal and in this class when we did this in UH Quiz 5, I believe. All right, here we go. Limit as h approaches 0. You're going to need two properties. We'll write the properties in a little bit. Of cosine x plus h minus cosine x all over h. I'm going to use this property right here to expand the x plus h, the cosine x plus h. So limit as h approaches 0, cosine x cosine h minus sine x sine h minus cosine x. All this is over h, and I'll slow down. Are we still okay? I'm going to move this right here, and then I'm going to push this to the right. Since there's no equal sign, we're going to keep the signs. So we're going to write limit as h approaches 0, cosine x cosine h minus cosine x minus sine x sine h all over h. I see that I can factor out a cosine x, and that's going to be unaffected because this is h approach 0, not x approach 0. So I'm going to write it like this. I'm going to write limit as h approaches 0. Here's my cosine x being factored out, and I have cosine h minus 1, and then I still have minus sine x sine h all over h. This is also a test question. I don't know if you remember. Are we still okay, guys? That's an x, so I'm going to do two limits. I'm going to do that limit, and I'm going to do that limit. But that cosine x is not being affected because it says h approach 0. So I'm going to write it like this. Cosine x limit as h approaches 0. There's just one of our properties. Cosine h minus 1 over h minus sine x limit as h approaches 0. Sine h over h. I'm going to come over here. I'm going to write side notes, guys. Side note. I need this property. Limit as h approaches 0. of cosine h minus 1 over h. That equals, do you guys remember? 0. And I need this property. Limit as h approaches 0 of sine h over h. That equals 1. I just learned about this little property that I can push star here and these things go away. Isn't that cool? Okay, yeah. And, well, the reason why I'm mentioning it is I've had Dropboard PDF, which is a software for like 4 years, and just recently did I learn about that. Okay, anyways, this right here is what? 0, and then this right here is 1. So here's what I have. I have cosine x times 0 minus sine x times 1. And look what I'm left with. Yep, negative sine x. So the derivative, so I'm going to put semicolon. So if f of x equals cosine x, that means f prime of x is negative sine x. Let me put the negative there. I'm running out of real estate. Let me push the little star there. There we go. Negative sine x. Oh, look, I got more real estate. LOL. And no yawning. That's a demerit. How do we feel? Good. So all these things come from somewhere. They just don't magically appear. So here's the rule. Do we have to do that every time? No. Just know derivative of sine x is cosine x. Derivative of cosine x is negative sine x. Here, let me give you the hack already, because you're going to see this in the future. If it starts with a c, it's going to be negative, the derivative. So write that down somewhere. If it's a trig function and it starts with a c, it's going to be negative. So you don't even know the derivative of cotangent yet, but I bet you know that it's going to be a what? Negative. You don't know the derivative of cosecant yet, but I bet you know that it's going to be what? Negative. So there it is. If it starts with a c, if it's a trig and it starts with a c, it's going to be a negative. So there's your hack. Cool or not cool? All right, so here it is, guys. Why do we need to know those? Well, look, now, what rule do I got to use to find the derivative of this? It's a what? It's a letter P. It's a product rule. So it wants me to find the derivative. Did you guys say product?
No.
Oh. What rule? I said rule, guys. What rule do I got to do? I thought I heard product. You guys said positive. LOL. Let the record show. Okay. This is all being recorded. Yeah, it's on record forever now. Okay.
Oh, okay.
LOL. Yeah, we're YWLA. We're pretty good. All right, here we go. Derivative. What do I do first, guys? Focus. What do I do first? What's the derivative of x squared? Oh, actually, no. First. First. Yeah, I know. You can actually do 2x if you want, but we're doing product rule, right? First times derivative of the second. What's the derivative of sine x? Cos x or cosine x. And then what do I do next? Plus, okay, you can say 2x, but what am I doing? Chop, what are you doing? I'm doing this, guys. I'm doing it the way I don't do it. Well, I guess you can if you want to. I'm doing this, u v prime plus v u prime. I'm going in that order. So try not to, well, I would prefer you have this habit than the other habit, but that's fine. First times derivative of the second plus second times derivative of the first. And if you want to write 2x in the beginning, 2x sine x, or if you want to reverse it, that's fine. There's a plus. If you want to have the habit that delta has, that's the habit that delta has. But here it is. I see most textbooks have it like that. I think I like it better, but it doesn't matter. If you want to go the other way, that's fine. In the second semester, we'll okay. Anyways, we're okay. Are we okay, guys? All right, we're done. We're just making it pretty. X squared cosine x plus 2x sine x. If you wanted to factor, I guess you could, but I'm going to leave it alone. Are we all right? Okay. All right. I don't know why I did that. Sorry. Matthew McConaughey, I think, does that all the time. You know who Matthew McConaughey is? No? Okay, then don't worry about it. He's a professor at UT. And he's also an actor, I think. All right, here we go. I'm taking the derivative. Notice that it says u. I'm going to take the derivative of u with respect to x. So I'm going to write it like this. du dx equals, what rule do I got to use? quotient. So tell me what I do first. Bottom times the derivative of the top. What's the derivative of cosine x? Negative sine x. Plus or minus? Minus the top times derivative of the bottom. Because there's a negative in front of the sine x, it's going to be a negative cosine x. Not because the derivative of sine x is negative, it's not, but I have a negative in the front, so I got to keep it. All this is over. Perfect. 1 minus sine x squared, or bottom squared. Make sure that you put parentheses. If you do not put parentheses and you just put 1 minus sine squared x, that's wrong because that's not correct. Are we still okay? Okay, you're done with calculus. Now let's see how your algebra or your pre-cal is. No. What? All right, here we go. Guys, focus. Let me see. Do I have enough space? I'll write it right here. Negative sine x plus sine squared x. And then what's negative times a negative? Plus cosine squared x all over 1 minus sine x close it squared. Are we still okay? There should be something that's sticking out that you guys should be saying, like, hey, wait a minute. The Valentine's formula. Sine squared plus cosine squared is equal to 1. So I have negative sine x plus 1 over 1 minus sine x close it squared. Is that it? Are we done?
Wait, isn't it the same thing?
It is the same thing. Notice that in the numerator and denominator, that one's a positive. Oh, look, this one's a positive. Oh, look, minus sine x. Oh, look, negative sine x or minus sine x. I think it's said B. So let me rewrite it for you guys. 1 minus sine x over parenthesis 1 minus sine x close it squared. What can I cancel? One of the binary pairs. Yeah, one of these. Bam, bam. Do you guys see what's going on? So my du dx, my final answer, if they ask it for simplified, 1 over 1 minus sine x. There it is. You could have said u prime, but I wrote du dx because I wanted to emphasize that I'm taking the derivative of u with respect to x. Yeah, I want to make sure that you guys know all the notation. What's up? Oh, what makes you uncomfortable? What happened?
She doesn't like it whenever I say usually.
Oh. All right, here we go. All right. Here we go, guys. Let's go to the next one. Relax. What is tens? What over what? All right, so I'm going to write d dx of sine x over cosine x. Are we still okay? Do we know the derivative of sine x? Do we know the derivative of cosine x? What rule am I going to use? Quotient. Let's start. Notice that I'm putting equals, and I'm no longer writing d dx, so that means I'm giving you the derivative of that. So what do I put first? Cosine x times, what's the derivative of sine x? Cosine x, just cosine x. So bottom times rid of the top, minus sine x times derivative of the bottom, which is
Negative sign. Why am I confusing myself?
yeah. Let's start again. Yeah, let's start again.
Don't start again.
No, I'm just gonna
Okay, I was like, wait.
bottom times derivative of the top. Bottom is cosine x. Derivative of the top. Derivative of sine x is cosine x minus top sine x times derivative of the bottom. The derivative of cosine x is negative sine x. Do you see where we're at?
Yes.
Okay. All this is over cosine squared x, or you can say cosine x in parentheses with a square on the outside. It doesn't matter. They're both the same, guys. Don't freak out. Are we still okay? All right, let's simplify this. What's cosine times cosine? Cosine squared x. Negative times a negative is a positive sine squared x all over We can't cancel.
Wait, the balance.
Oh, because
Yeah.
it's adding
It's adding. Cosine squared plus sine squared is equal to 1.
Wait.
All right, I'm waiting. Yes, 1 over cosine squared. You could leave it like that. But there's a better answer. 1 over cosine squared is? Look at that, you silly goose.
Oh my god! No, you forgot the silly goose. It's
No,
too silly.
I'm not going to say too silly.
Then you're a silly goose.
Oh, okay. Are we okay with what we got here? So from now on, by the way, are you going to be doing this forever and ever like that? What do you think we're going to say? From now on, the derivative of tan x is simply? Perfect. The derivative of tan x is simply secant squared x. And let me go ahead and give you the other one. The derivative of secant x, we can, by the way, derive this, but the derivative of secant x is secant x tan x. Let me know if you want to see a derivation.
Can you give us like a chart with all of
Yes, I'm going to give you a chart with all the derivatives and all the rules.
Yay! Oh my god,
All right.
I'm so excited.
You guys ready? Hey. Positive vibes only. And that sounds so ugly. If you're going to tell someone, and if you're listening to this, please don't give me a thumbs down. Give me a thumbs up. All right, here we go. I can assure you, family and teachers, that this is a safe space, because I already know I'm going to forget to delete that. All right. It is a safe space. No one's being bullied. Everyone's happy. Let's continue. All right. No. Hey, come on. Focus, guys. Focus. So look what they asked me here. They want the derivative evaluated at? All right. So here we go. G prime of x equals, what's the derivative of x? 1. What's the derivative of 2 cosine x? No. Negative 2 sine x. Good job. Because there's a 2 in the front. The derivative of a constant is 0, but it's not. Okay. Side note, let's talk. No. We're going to talk because I'm sure others have the issue. All right, guys. Focus. So I have this 2 cosine x. And so some of you are tempted to say, well, Chop, why can't I use product rule? And I guess you can if you want. But look, you're being extra. Look, if I do product rule first, times derivative of the second, plus second, derivative of the first, and look what you get. 2 times negative sine x, that's negative 2 sine x. And this is just 0, so you just get negative 2 sine x. Do you see that? You've actually been doing that. So look, this is still part of my side note. You've actually been doing that even when you do something like this. Remember in the beginning we said leave the 5 alone, and then what's the derivative of x squared? And you said 2x, and then we got 10x. See, it's the same deal, guys. You don't have to do that. You can just go 5 times 2. You can actually do product rule with that too if you want. First times derivative of the second, plus second, derivative of the first, and then look, you still get your 10x. Do you guys see what I'm talking about? So if you have a constant in front of your trig, there's no need to do product rule or anything. Just take the derivative of cosine, leave the constant alone. So the derivative of 2 cosine x is negative 2 sine x. Are we cool? Okay. Did I answer all your questions? Okay.
So if we had like,
Go ahead.
2 cosine squared x.
You have to do chain rule on that, but we're not there yet. But if you had 2x times cosine x, then you have to do product rule.
Where did the 0 come from?
The derivative of a constant. If I were to do first under the second plus second under the first. If.
Oh, wait, so that's not what part of the problem? Or...
No, this is not part of the problem. This is a side note. What's up? Oh, we don't know that yet, but I'm going to tell you. All right, here we go, guys. Take a guess. Check it out. If the derivative of tangent is secant squared, what do you think the derivative of cotangent is? Negative cosecant squared. Look at that. Context clues. Did you know that already in advance, or you just use the context clues? So there it is. You already know it. All right, let's do one more. If the derivative of secant x is secant x tan x, what do you think the derivative of cosecant x is? Think about it. Look, derivative of secant x is secant x tan x.
Oh, cotangent x.
Negative cosecant x cotangent x. So if you just memorize the derivative of tan and secant, you already know the cotangent and cosecant by using context clues. Are we cool? You can derive any of them by chance. You can derive all of them if you wanted to from scratch, but it's better to just know them. All right, coming back. Here we go. What do you say the derivative of cotangent was? There it is. Now here comes a little bit of pre-calc, not even extreme, just a little bit, guys. Just a little bit of pre-calc. G prime of power 4 equals 1 minus 2 times what sign of power 4?
Pardon the interruption, students and staff. I do apologize. It appears that we have a Canvas outage that district IT is aware of. Any students that are experiencing this impact, I apologize for the inconvenience. Teachers, please do not send students to the front office for this issue, as we are waiting on district guidance to resolve the problem. If you have any concerns, please reach out to the administrator. Thank you.
It's a technology issue.
Yeah, no
We're fine.
comments.
No, well, that's my hotspot. We'll see. All right, here we go. You guys ready? Cosecant of power 4. Well, power 4, both x and y are the same, so they're making it easy for us. Cosecant is just a reciprocal, so we're going to go 2 over square root of 2, close it, put a square on it because it says squared. Are we still okay, guys? All right, let's see what this is. 1 minus, these 2's cancel out, so square root of 2. Minus, when I square that, 2 times 2 is 4. And square root of 2 times square root of 2 is 2. 4 over 2 is just 2, right?
Yeah.
What's 1 minus 2? Negative 1. Negative 1 minus square root of 2. Look for that answer. They wrote the radical first. It's not a big deal. Yay or nay?
This is so funny.
Yeah, not that bad.
It's a.
It's not that bad.
Please recite these before going to bed every night.
Yeah, I wrote that.
Like a prayer?
So in short, we can do the same methods to find the derivative of other trigs. So here they are, guys. Here's the derivative of all the ones that we just talked about. Please recite these before going to bed every night when you do your prayers. No, you'll know it for a fact. I'm telling you, this is what we got to do. When you're going to bed, you'll go like, derivative of tan x is, what's the derivative of tan x? Secant squared. Like, just recite it. You'll be fine. Yes. Yeah, see? Gonzaga knows what I'm talking about. All right, here we go, guys. I guess we'll use Desmos on this one. Oh, you know what? No, I already said calculator, so we're going to use a calculator. Does everyone have a calculator? Okay. I'm going to show you 2 ways on how to find this derivative. So let's see. It says, find the equation for the lines that are tangent and normal to the graph of tan x over x at x equals 2. So here we go. You guys ready? So what do I need if I want to get a tangent line? What and what? Point and a slope. So I'm going to type in 2 and get my y value. By the way, every time you get your values from the calculator, at least how many digits after the decimal? Yeah, the more the better. I was going to say 3, but if you put 4, that's fine. 5, better, that's fine. So here we go. I'm going to type tan 2 divided by 2. Since I just have one term, I just did that. You know what? Now let's have better habits. Alpha y equals, enter, tan 2. That way we'll never get it wrong. Divided by 2, enter. And there it is. Negative, FERPA. Okay, remind me to delete that. It's because I had grades up there. Negative 1 point. Oh, what time is it? 10:30. So remind me, guys. 10:30. I really do gotta delete that because we can't showcase grades to the whole world. Negative 1.0925. Close it. If you want to be perfect, which actually, okay, there's no such thing as perfect. But if you're gonna need that answer for future references, I would store it. So how do you store it? Push the stow button. And then alpha A. I just go down the alphabet. So there it is. It's an A. And now I want my tangent slope, right? So I'm gonna tell my calculator, I'm gonna go d dx. Don't worry, I'm gonna show you how to get that. Tan x over x. evaluated at x equals 2. So there it is. My derivative of tan x over x evaluated at x equals 2 is, so take your calculator. You guys ready? Push the math button. Scroll down until you see numeric derivative. So in mine is number 8. Actually, for everyone should be number 8. Push enter, and then you'll get this notation. Put an x in there. Okay, I'm going to do it again. Math, and then you see it, number 8. Push enter, and then put x right here. And then in here, you're going to put tan x over x. Don't put the number because it's going to get 0, because derivative of constant is 0. Alpha y equals, enter, tan x over x. And I have the value, actually at x equals 2, so I don't need that right there. Just put 2 right here. At x equals 2, that's where I want the derivative. So I'm going to push enter. 3.433. 3.433. Let me put more digits. 478. What? Okay. I'm going to store that to be on my calculator. Child, why are you doing that? You're being so extra. I guess you don't have to, because this one's pretty straightforward, but I want to get in good habits here. Oh, yeah, you might be in degree mode. Are you in degree mode? Let me see.
Can we do that trend in Friday? You weigh just as much as me.
Probably different tolerances, but that's okay. The first 3 digits, 433, that's all we care about. You know what I mean? All right. Does anyone else have a different value when you type this in? Oh, you got the same or different? Yeah, perfect. Yeah. All right, guys. So check it out. Here's what I'm gonna do. I want to see how this looks in my calculator. I'm gonna type this into y1, and I'm gonna show you a different way that you could have done it. Tan x over x, and then I'm gonna go to y2, and I'm gonna type in. Let's see, what am I gonna type in? Y minus or plus 1.0925 equals my slope 3.433478. That's an 8. X minus 2. Okay, so I'm just going to move that to the right. All right, so here's what I'm going to type. I'm going to go y1 alpha y equals. Say it again. Say it again.
Do I just put the y equals?
Oh, no, I'm solving for y, so I just move this 1.09 to the right.
Oh, okay.
All right. So look, remember that I have the slope saved in b in my calculator? At least I think I did, right? So I'm going to put alpha b, parenthesis, x minus 2, close, minus, and I think I have that 1.0925 saved as a, no? So I'm going to put minus a. Actually, plus a because my a is negative. Yeah, plus a because my a is negative, guys. Yeah, window. Actually, let's see how it looks just right now. Okay, you see how it's just that one? So I'm going to go from 0 to 1, 2, 3, 4. I'm going to go 0 to 4 in the x. So 0 to 4.
How do you get it to go so fast, Charles?
Oh, because it's in the computer. So yours is going to go slower. And yeah, that looks like a tangent line. Look at that. Cool, right?
Oh, there we go.
Yeah, it looks tangenty. I just going x min 0, x max 4, and I left the y alone. Yeah, my calculator is going to go a lot faster, guys, because it's a computer. The code runs way quicker. Yours is going to go slower. What's up? Yeah, I put plus a because my a is negative. If you do it on Desmos, you can write it. No, it was positive, and then when I moved it to the right, it turned negative. But when I solved it here, it was already negative because it's just a point. Well, yeah, because this is my point, miss. So y plus 1.0925 equals 3.433 parentheses x minus 2. And when I move it to the right, it turns negative. Because my a was already negative. Look, my a was already negative. A, negative 1.09. So when I move it to the right, it turns negative because it was y minus a negative. Initially, yeah, maybe I'm confusing you. See, when I did my point formula, y minus that negative turns to other, right? Slope, x minus 2. And then when I move it to the right, well, that's subtracting now. So y equals 3.43 x minus 2 minus 1.925. But since I already have stage A as negative value,
Oh,
plus
okay.
all right. On the AP exam, guys. All right, focus, focus, focus. On the AP exam, you will have access to Desmos and you will have a calculator. There are some things that I prefer Desmos over. Like on this one, I think I probably would prefer Desmos. But there are some things that I prefer the calculator over. Anytime there's multiple calculations that you got to do, you're not going to have the cut paste feature on your Desmos. Right now, when you use Desmos, you have the full features, right? You can cut and paste. But on the AP exam, the cut paste feature is not available. So for if there's multiple steps that you got to do, I still prefer the calculator, but I'm going to leave that up to you, what you feel most comfortable with. Desmos is pretty good. It's very strong. Desmos is really good for finding zeros. You just click. Desmos is really good for maximums. You just click. But I still like the calculator for things that require several steps. That makes sense, guys? Okay. And don't worry, we're going to practice. Are we okay with that one there, guys? Okay. What?
Be quiet.
I don't,
So what is the y equal?
It says YA right
What are the what?
Y to the power of
I thought it was the b times
Those are
the
the primes.
x minus 2.
Yeah, that was my tangent slope.
Okay.
Second derivative.
All right. Here we go. Yeah, y prime prime. That means what, guys?
Second derivative.
All right, so here we go. Y prime equals what's the derivative of secant x?
It's secant x plus
No, not plus.
plus 10.
Yeah, times tan x. Now I got to do the derivative again. What rule do I got to use? Product. Underline the first, underline the second. Y prime prime equals first times derivative of the second. What's the derivative of 10? Perfect. Are we still okay? Plus the second, and use parentheses, guys, and then we'll take care of the parentheses afterwards, times derivative of the first. What's the derivative of secant x? All right, now we're going to make it pretty. Secant times secant squared is going to be secant cubed x. You can either put it in parentheses and the 3 on the outside, or you can put the 3 immediately after the c. Plus, and then tan x times secant x tan x. Secant x tan squared. You can make a case for factoring out a secant, but I wouldn't. I would just leave it like that. How do we feel? Okay, now it's all about practicing. Don't worry, we still got a handout, but I think Delta does a really good job about giving you guys practice. So let's do a practice today, and then tomorrow I'll give you guys a handout that we can practice. Cool? We are now also good. You know we have to add the UH quiz, right? UH quiz, I already forgot the number, but I remember the name. Derivatives 1.
I think it's like
7. UH quiz 7. All right, guys. Log into Delta and practice.